Hi, I'm Carl, and in this video we're going to have a look at questions 14 and 15 of section 3 of the orange booklet. So this is a question that explains how the body fluids of fish in cold waters that are below 0 degrees Celsius don't freeze. And we're told this is because of the presence of solute particles. We're given then an equation that describes something called freezing point depression, which is where freezing point can dip below 0 whenever stuff is dissolved in solution. We're told then that this is due to the number of particles that are bonded with the water that are dissolved in this solution. 14 says in benzene, benzoic acid molecules form dimers, which are held together by hydrogen bonds. And I've drawn this diagram out here. It says because of this association, the freezing point depression of a 0.01 molar solution of benzoic acid and benzene will be what? So this equation at the top tells us that the decrease in freezing point, so this delta TF, is proportional to the molarity. And molarity is really just a measure of how many molecules are present. Whenever we've got two molecules on this side, which then go on to form a dimer, which is made up of one molecule, whenever this association happens, we're actually halving the amount of different particular molecules that are there. So two molecules stick together to form one molecule, and so that halves the molarity. And if molarity is proportional to the freezing point depression, that means it's going to be half the theoretical value, which means the answer to number 14 is going to be A. If we look at 15 then, we're given some numbers to work with. So let's look at this equation. We've got our decrease in freezing point, and that's going to be equal to the constant multiplied by the molarity and the number of moles. And the way to write moles is going to be the mass over the molar mass, which I'll write as MR here. We'll call the molar mass X and calculate it then. So we're told that we have 40 grams of a non-electrolyte solute in 1000 grams of water with a freezing point that is 0.4 degrees before that of pure water. Okay, so we've got our delta TF of 0.4, and we're told our KF is going to be 1.86 per mole per kilogram. So that's 1.86 here. We multiply that by the molarity, which we'll call the mass over X. We're told the mass is going to be 40 grams of this substance, and we'll divide it by its MR, which we'll call X. Great. We've got an expression here, which is 0.4 equals 1.86 times 40 over X. I think this is an easiest way of saying it. So then we can rewrite this and say that X is going to be 1.86 times 40 over 0.4. If we divide both, or on a fraction here, if we divide both sides, the top and the bottom, by 0.4, we get 1.86 multiplied by 100 equals X, and that gives us an answer of 186, and that is answer D. So that was question 14 and 15 of section 3 of the orange booklet. I hope that helped. Thanks for watching.